sing it. Come on, get happy.
This set of notes is about oxidation numbers, and we're going to use the metaphor, what makes atoms happy. Remember we said that the octet rule said that atoms are, and we put this in quotes, the happiest when they have 8 valence or outer electrons. Again, atoms don't actually have emotions. They're not happy. This is a metaphor, and in this case, happy means that they are stable, that they are not looking to go around bonding with other atoms. So atoms are the most stable when they have 8 valence electrons. So let's ask, what's the quickest way to make this particular atom happy? Here's the Lewis dot diagram for a fluorine atom. Remember, Lewis dot diagrams show us the outermost or valence electrons. In this case, fluorine has 7 valence electrons. The easiest way for it to get happy is to gain 1 more. That's easier than taking away the 7 in this shell and looking at what's underneath that. So we can add 1 electron. And then it has the 8 electrons that meet the octet rule, and now it's happy. But it's no longer an atom. When it adds that electron, it becomes an ion. To show the Lewis dot diagram for an ion, we're going to do 2 things. First, we're going to put it in brackets. This is like an alert to someone who's looking, hey, this is an ion, not an atom anymore. And then we're going to show the charge along with the sign, either positive or negative, outside those brackets. This fluorine gained a negatively charged electron, so it has a charge of -1. And now it's a happy ion. So it went from an unstable atom to a stable ion. We're going to learn about oxidation numbers. The precise definition of this is the number of electrons an atom gains, loses, or shares when it forms a chemical bond. A slightly more useful definition for us will be to think of what's the charge on a happy ion. That is, an ion that's meeting the 8 valence electrons octet rule. Oh, random trivia. According to Wikipedia, what is the world's smallest mammal? Since you're on a computer listening to this, you are most welcome to go find that for yourself. Here's a cute little picture of the thing, but I would challenge you to go find the answer to this random trivia all on your own. Okay, so how do we find oxidation numbers? Step 1, we have to start with the atom and figure out how many electrons it has to begin with. Step 2 is we're going to draw a Lewis dot diagram that shows the valence electrons only. Step 3 is we're going to count how many electrons the atom would need to gain or lose to meet that octet rule. That's going to give us the number part of the oxidation number. And then we need to figure out the sign, positive or negative, of the oxidation number. The oxidation number will be negative if the atom gains negatively charged electrons. The oxidation number will be positive if the atom loses those negatively charged electrons. Because remember, taking away a negative charge will result in something that is more positive. Let's do an example to find the oxidation number for oxygen. Step 1 said, figure out how many electrons the atom has. So for oxygen, it has an atomic number of 8. That means it has 8 protons, and so it has 8 electrons in its neutral atom. Those 8 electrons go 2 in the first shell and 6 in the second shell. The next step then is to figure out how many valence electrons this has. We're going to draw a Lewis dot diagram showing those valence electrons. So here's oxygen, and it's 6 outer shell electrons, shown as 6 dots evenly spaced around its chemical symbol of O. Step 3 is to count how many electrons the atom would need to gain or lose to meet that octet rule. And this is going to give us the number part of the oxidation number. So for oxygen, the easiest thing to do is for it to pick up the 2 extra electrons that it would need to make an outer shell that feels happy with 8. In this case, it's going to gain 2 electrons. So the number part of the oxidation number is going to be 2. To figure out whether it's positive 2 or negative 2, we need to look at the sign of the oxidation number. The number is negative if the atom gains electrons, and positive if the atom loses electrons. In this case, it gained 2 electrons. It got 2 more negative charges, so that oxidation number is negative.